Hey, this is the second video of our FTC programming course. This one will be about servos and the Rev touch sensor. If you don't have a touch sensor at the moment, that's fine. You just don't have to actively follow along when it's needed. Alright, so last video, we kind of just copy pasted this code and I didn't really explain what any of this does. So since we're gonna start getting to programming, I'll explain it now. So this is our op mode class, and it extends the linear op mode class. So this is a certain type of op mode that makes it easy for us to make our own op modes. What we're doing is we're overriding the run op mode method of linear op mode. And this is basically a method that just gets called over and over and over again while the op mode is running, or while the robot's running, and this allows us to pretty easily write some simple op modes. So the first thing we're doing is calling wait for start, another method from linear op mode, and this just waits for us to press the start button on the driver hub. Op mode is active is another method that just returns whether or not the robot is currently running, or the op mode is currently running. This is pretty necessary. And then telemetry, it's an attribute of linear op mode. It allows us to interact with the console on the driver hub. So add data, it's just a key value method. We can give it a caption and then a value, which is any object. We gave it a string here. And then once every loop, we have to update the console to actually see the things displayed. And then this teleop tag, all it does is it adds the op mode to the list on the driver hub. And I gave it a name here, Servo test. Changed it from the default name. So there's actually a couple different kinds of servos. There's positional control servos, and there's continuous rotation servos. So continuous rotation servos, you can tell them what direction and how fast to move. While position control servos, they have a certain range of motion, and you give them a position within that range of motion of where to move. So in this video, we'll talk about position control servos. So you'll need one of those. Some servos can do both, like the Go Builder ones, I'm pretty sure. So if you have one of those, you have to use your servo programmer to set it to position control. Let's configure the servo on a robot. So we can press configure robot, and then on your configuration, select your configuration in the control hub, servos, and then I have mine plugged into port 0. So on 0, I want to set it actually to servo, crucially, and then I give it a name, test servo. So we can press done and save the changes. Now we can interface with the servo with our code. Okay, let's write some code for our servo. So first we have to get our servo from the hardware map, which is where we configured it. So we can create a new variable of the servo type and use the hardware map.get method. So you give it the servo class, and then you just give it the name of your servo. So ours was test servo. And hardware map is another attribute of linear op mode. So now a function of servo that we can use is set position. So yeah, sure, 0.5 works, but let's actually just do this inside of our loop. So now when you run it, the servo will go to the middle position. But let's make something a bit more interesting. So we can actually use the time of the op mode. So we can use the get runtime and then modulo 3 is less than, I don't know, maybe 4, and then less than 2. And now basically every 2 seconds it will alternate between position 0 and position 1. Yeah, let's test it out. We can upload our code. Okay, now theoretically, when we run our op mode, the servo should alternate between its minimum and maximum position every 2 seconds. Let's see. Okay, that worked. Cool. Let's try using the touch sensor. So we can plug it into one of the digital ports. I'll plug it into the 0 and 1 port. And we're going to configure it as plugged into port 1 because it actually only uses the 3rd and 4th pins, which are for 1. Okay, let's configure it. So here we can find our digital devices. Then in port 1, rev touch sensor. And then I'll type name. Just call it touch. And save it. Let's try using the sensor in our code. So let's get the sensor from our hardware map. Let's call it touch sensor. And then we can grab it in the same way that we got the servo. I actually just called it touch. And then maybe we can change this to touch dot is pressed, and servo, the touch sensor is just a button, so all it gives is a boolean. So now if the button is pressed, the servo will go to 0, and when you let go, it'll go to 1. So let's try uploading it. All right, let's test it. So running it, it's at position 1 right now. When I press this, it'll move to position 0. And when I let go, back to 1. That works. The last thing we'll do is we'll try to print the target position of the servo into the console. So let's just change the message here to target servo position, and then instead of the string, we can use the get position method. So get position is a bit misleading. It doesn't actually give you the current position of the servo, but it gives you the last target that you gave it. So the last time you called set position, it'll give you that number. So let's upload that. Okay, I'm running it. So okay, so right now our target position is at 1. When I press it, it'll change to 0. Now it's 0. Now it's 1. Now it's 0. Cool. So we know that works. Okay, so finally we're gonna commit our changes to our GitHub repository. So here's our commit tab. You can check off all the changes we made since the last video. And now we can type a message. Let's say servo test. And now we can commit and push. And now on GitHub, we can see that it received our push. And our latest commit is servo test.